NENOMATICA, where mathematics meets YouTube excellence. Example: the problem is 16x to the 8th minus 17x to the 4th plus 1 equals 0. Step 1. Use an auxiliary variable to reduce the degree. We set y equal to x to the 4th power. Then y squared is x to the 8th. Substituting into the equation gives 16y squared minus 17y plus 1 equals 0. Step 2. Solve the quadratic in y. Notice that 16 plus negative 17 plus 1 equals 0. For a quadratic, a y squared plus by plus c equals 0. If a plus b plus c is 0, then one root is y equals 1, and the other root is c over a. Here, 16 minus 17 plus 1 equals 0. So the roots are y equals 1, and y equals c over, which is 1 over 16. Step 3. Back substitute to find x. From y equals 1, we get x to the 4th equals 1, which gives x equals plus or minus 1. From y equals 1/16, we get x to the 4th equals 1 over 16, so x equals plus or minus 1/2. To build intuition, let us place the solutions on a number line. We mark -1, -1/2, +1/2, and +1. Final answer: x equals 1, -1, 1/2, and -1/2. Recap. We use the substitution y equals x to the 4th to turn an 8th degree equation. In this example, we will solve the equation x to the 6th minus 19x cubed minus 216 equals 0 using a clean substitution strategy, then the discriminate, and finally the quadratic formula to get the solutions for x. Step 1. Substitution. Notice that x to the 6th equals parenthesis x cubed parenthesis squared. So we set y equal to x cubed. That turns the equation into a simpler quadratic in y. Y squared minus 19y minus 216 equals 0. Here, at equals 1, b equals -19, and c equals -216. Quick challenge. Can you say the coefficients a, b, and c out loud? Step 2. Compute the discriminate delta. Delta equals b squared minus 4ac. Plugging in the numbers, we get -19 squared minus 4 times 1 times -216. That is 361 plus 864, which equals 1,225. Step 3. Solve for y using the quadratic formula. The formula says y equals -b plus or minus the square root of delta, all over 2a. Substituting our values, y equals -19 plus or minus the square root of 1,225 over 2 times 1. That simplifies to y equals 19 plus or minus 35 over 2. Step 4. Convert solutions for y back to x using y equals x cubed. First branch, 19 plus 35 is 54. 54 divided by 2 is 27. So y is 27, which means x cubed is 27, and therefore x equals 3. Second branch, 19 minus 35 is -16. Dividing by 2 gives -8. So y is -8, which means x cubed is -8, giving x equals -2. Our real solutions are x equals 3 and x equals -2. In this example, we'll solve a quadratic equation in disguise using a helper variable substitution. We'll follow a simple, visual, step-by-step approach. Here is the problem. First, we'll show the word example, then the equation. Notice the repeating part 10 squared over 3 minus 2. We'll leverage that to simplify. Step 1. Identify the repeating part and introduce a helper variable. We'll use substitution. Let y equal x squared over 3 minus 2. This lets us rewrite the equation in a simpler form. Step 2. Rewrite the original equation using y. We are transforming a disguised quadratic into a standard one. Therefore, y squared minus 7y plus 6 equals 0. Step 3. Factor the quadratic in y. We look for two numbers that multiply to +6 and add to -7. Those are -6 and -1. So the factorization is left paren y minus 6 right paren times left paren y minus 1 right paren equals 0. Step 4. Solve each factor. First, set y minus 1 equal to 0. So y equals 1. Now back substitute to solve for x. If y equals 1, then x squared over 3 minus 2 equals 1. So x squared over 3 equals 3, then x squared equals 9, and finally x equals plus or minus 3. Step 5. The second factor gives the other value of y. Set y minus 6 equal to 0, so y equals 6. Again back substitute for x. Then x squared over 3 minus 2 equals 6, so x squared over 3 equals 8. Thus x squared equals 24, and x equals plus or minus the square root of 24, which simplifies to plus or minus 2 times the square root of 6. Therefore, the complete solution set is x equals plus or minus 3, and x equals plus or minus 2 square root of 6. In this lesson, we will solve an equation using the auxiliary variable method. Example: solve the equation open parenthesis 4 minus x squared close parenthesis squared minus open parenthesis 4 minus x squared close parenthesis equals 12. Notice the repeated expression 4 minus x squared. Since it repeats, we can simplify the algebra by substitution. Let y equal 4 minus x squared. Then the equation becomes y squared minus y minus 12 equals 0. Now we factor the quadratic. We look for two numbers that multiply to negative 12 and add up to negative 1. Those are negative 4 and positive 3. So we get open parenthesis y minus 4 close parenthesis times open parenthesis y plus 3 close parenthesis equals 0. From the factored form, set each factor to 0. That gives y equals 4 or y equals negative 3. Case 1. If y equals 4, then 4 minus x squared equals 4, which gives x squared equals 0. So x equals 0. Case 2. If y equals negative 3, then 4 minus x squared equals negative 3. So x squared equals 7, and x equals plus or minus square root of 7. To visualize the solutions on a number line, we mark x equals 0 at the origin, and x equals plus or minus square root of 7, which is approximately plus or minus 2.645. Therefore, the solutions are x equals 0, and x equals plus or minus square root of 7. Final answer. Here is the example we will solve x to the 2/3. Minus 2 times x to the 1/3 minus 15 equals 0. Step 1. Spot the exponent pattern. Notice that 2/3 equals 2 times 1/3. This tells us one exponent is exactly double the other. Step 2. Define the substitution. Let u equal x to the 1/3. Then u squared equals x to the 2/3. Step 3. Rewrite the original equation completely in terms of u. X to the 2/3 becomes u squared. X to the 1/3 becomes u. So the equation becomes u squared minus 2u minus 15 equals 0. Step 4. Factor the quadratic. We need two numbers that multiply to negative 15 and add to negative 2. Those numbers are negative 5 and positive 3. So the factorization is open parenthesis, u minus 5 close parenthesis times open parenthesis, u plus 3 close parenthesis equals 0. Step 5. Solve each factor and back substitute. From u minus 5 equals 0, we get u equals 5. Since u equals x to the 1/3, that gives x equals 5 cubed, which is 125. From u plus 3 equals 0, we get u equals negative 3. Then x to the 1/3 equals negative 3, and x equals negative 3 cubed, which is negative 27. Always verify solutions by substitution. Plug in x equals 125. The cube root of 125 is 5. 5 squared minus 2 times 5 minus 15 equals 0. Plug in x equals negative 27. The cube root of negative 27 is negative 3. Negative 3 squared minus 2 times negative 3 minus 15 equals 0. Both check out. We will solve a power equation using the auxiliary or substitution method step by step with clear visuals and checks along the way. First, let's show the example. We will solve the equation y to the negative 6 minus 9y to the negative 3 plus 8 equals 0. Note that y cannot be 0 because of the negative exponents. Step 1. Identify the relationship between the powers. We use the power relationship rule. Observe that negative 6 equals 2 times negative 3. This tells us the higher power is exactly the square of the lower power. Step 2. Define the auxiliary variable. We apply the substitution method. Let u equal y to the negative 3. Then u squared equals y to the negative 6. Step 3. Rewrite the equation using the substitution. Start from the original equation. Replace y to the negative 6 with u squared and y to the negative 3 with u. We obtain u squared minus 9u plus 8 equals 0. We will color the changed parts in orange for clarity. Step 4. Factor and solve for u. Use the factoring rule for quadratics. We need two numbers that add to negative 9 and multiply to positive 8. Those are negative 8 and negative 1. So the factorization is left parenthesis u minus 8 right parenthesis times left parenthesis u minus 1 right parenthesis equals 0. Therefore, u equals 8 or u equals 1. Step 5. Back substitute to find y. We use the negative exponent rule. Case 1, u equals 8. Then y to the negative 3 equals 8. That is 1 over y cubed equals 8. So y cubed equals 1/8 and y equals 1/2. Case 2, u equals 1. Then y to the negative 3 equals 1. So 1 over y cubed equals 1. Hence y cubed equals 1 and y equals 1. Therefore, the solutions are y equals 1/2 and y equals 1. Example. We will solve the equation z minus 9 times the square root of z plus 14 equals 0 using a substitution method that removes the square root. Step 1. Define the auxiliary variable. Let u be the square root of z. Then, u squared equals z. This turns the radical into a simple variable. Step 2. Substitute into the original equation. Replace z with u squared and the square root of z with u. We get a standard quadratic. U squared minus 9, u plus 14 equals 0. Step 3. Factor the quadratic. We look for two numbers that multiply to 14 and add to negative 9. They are negative 7 and negative 2, so the factorization is left parenthesis u minus 7 right parenthesis times left parenthesis u minus 2 right parenthesis equals 0. Step 4. Solve for u, then back substitute to find z. From u minus 7 equals 0, u equals 7. Then the square root of z equals 7, so z equals 49. From u minus 2 equals 0, u equals 2. Then the square root of z equals 2, so z equals 4. Quick check. Since z must be non-negative, both solutions are acceptable. A quick substitution confirms. With z equals 49, the square root of z is 7. With z equals 4, the square root of z is 2. Both satisfy the original equation. Final answer. Z equals 49 and z equals 4. Example. In this lesson, we will solve the equation 2x to the 10th minus x to the 5th minus 4 equals 0, using a clean substitution that reduces the equation to a quadratic in a new variable. Step 1. Define the auxiliary variable. Because x to the 10th is the square of x to the 5th, we let u equal x to the 5th. Then, u squared equals x to the 10th. Step 2. Substitute and rewrite. Replace x to the 10th by u squared and x to the 5th by u. The equation becomes 2u squared minus u minus 4 equals 0. Step 3. Solve the quadratic for u. We use the quadratic formula, u equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. Here a equals 2, b equals negative 1, c equals negative 4. The discriminant is 1 minus 4 times 2 times negative 4, which is 33. Therefore, u equals 1 plus or minus square root of 33, all over 4. Step 4. Solve for x from the first value of u. Using a calculator, 1 plus square root of 33 over 4 is approximately 1.68614. So x to the 5th equals 1.68614, and x is the real fifth root, approximately 1.1101. Step 5. Solve for x from the second value of u. 1 minus square root of 33 over 4 is approximately negative 1.18614. So x to the 5th equals negative 1.18614, and the real fifth root is about negative 1.0347. In this example, we'll solve the equation x to the 6th minus 9x cubed plus 8 equals 0 using the substitution method, step by step, focusing on intuition and clean algebra. Step 1. Notice that x to the 6th is the square of x cubed. We can rewrite the equation as open parenthesis x cubed close parenthesis squared minus 9 times open parenthesis x cubed close parenthesis plus 8 equals 0. To make it look exactly like a quadratic, let y equal x cubed. We'll highlight the x cubed pieces and show the substitution mapping from x cubed to y. Step 2. Substitute y for every x cubed. This turns the original equation into a simple quadratic in y squared minus 9, y plus 8 equals 0. Step 3. Factor the quadratic. We need two numbers with product 8 and some negative 9. Those numbers are negative 1 and negative 8. So the factorization is open parenthesis, y minus 1 close parenthesis times open parenthesis, y minus 8 close parenthesis equals 0. Step 4. Set each factor to 0. That gives y equals 1 or y equals 8. Since y equals x cubed, we have x cubed equals 1 or x cubed equals 8. Taking real cube roots gives x equals 1 and x equals 2. Quick recap. The original equation is actually a quadratic in x cubed. It factors as open parenthesis x cubed minus 1 close parenthesis times open parenthesis x cubed minus 8 close parenthesis equals 0. Over the real numbers, this gives x equals 1 or x equals 2. Equals 1 or x equals 2. In this example, we will solve the equation x to the negative 4 minus 7 times x to the negative 2 minus 18 equals 0. We will use a helper substitution to turn it into a simple quadratic. Step 1. Rewrite using the common power x to the negative 2. We notice that x to the negative 4 is the square of x to the negative 2, so we write open parenthesis x to the negative 2 close parenthesis squared. Minus 7 times x to the negative 2 minus 18 equals 0. Then we set x to the negative 2 equal to y. Step 2. Substitute y for x to the negative 2. This becomes a standard quadratic in y squared minus 7y minus 18 equals 0. Step 3. Factor the quadratic. We want two numbers that multiply to negative 18 and add to negative 7. Those are negative 9 and positive 2. So the factorization is open parenthesis, y minus 9 close parenthesis times open parenthesis, y plus 2 close parenthesis equals 0. Step 4. Solve for y, then return to x. From the factors, either y equals 9 or y equals negative 2. Now recall that y equals x to the negative 2, which is 1 over x squared. So if y equals 9, then 1 over x squared equals 9, which means x squared equals 1/9, so x equals plus or minus 1/3. If y equals negative 2, then 1 over x squared equals negative 2, which would require x squared to be negative 1/2, which is impossible over the real numbers. Therefore, that branch has no real solution. So the real solutions are x equals plus or minus 1/3. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.